So it's HDRI theory time again. Horo was kind enough to watch my videos about using the Bryce sky as a HDRI, and although he said I hadn't said anything horribly inaccurate, I had not entirely provided you with something that was necessarily correct in all cases, because of the way that Bryce uses, I'll read it from his email, Bryce uses a median cut algorithm, and this one divides the HDRI into squares of different sizes, and each square gets a point light. The point lights have all the same intensity but vary in colour. A bright spot has several small squares huddled together, and a darker part a few large ones. So if you have a blue cloudless sky with the sun, most of the light sources cluster in tiny squares where the sun is, and only a few are left in larger squares. So with a quality of 16, which has 24 lights, chances are that you have 20 light sources packed around the sun, 2 in the rest of the sky and 2 below the horizon. Potentially, but bear in mind every time you generate the HDRI and then it's sampled, you get a different distribution of light. So rather than just guess, what I thought I'd do is try and create a situation where we can actually see the distribution of lights, at least roughly, using the tools we have in Bryce. So I'm going to begin by creating a default sphere. I'll get rid of this infinite plane and modify the material on this sphere initially so that we have a specular highlight. If I make the halo black, it gives me a very small specular highlight, as small as possible. But our difficulty is that HDRI images don't produce a very much specular output. So what I'm going to do is drive this with a hypertexture. So I'll just load in a hypertexture to give this some power. There we go. And the thing is that if I make this transparent, the light goes through it and lights the inside, so I can't have it transparent, but I do want to see the full distribution. So if I place my camera inside this sphere, I'll put it at the world origin like that, and then put the sphere at the world origin, and then I'll go to panoramic projection and give this a render. It's fully black, but if I then turn off shadow casting, you can see that the lights come through, and this is the specular highlight that has come from the sun. However, if I've got the sun vertically above us, because the top and bottom are chopped off in the panoramic projection, I'm going to need to use something to get that in, and we've got the spherical mapper somewhere here, so I'll use that little tool and also align that with the world origin. So now we get a full spherical projection. So because the sun's at the top and it's coming through the wall of the sphere, because it's not casting shadows, I'm getting this effect at the bottom. So to correct for that inversion, I'll take my camera and rotate it 180 degrees around the z-axis. So now hopefully when I reposition the sun in the sky, I will get corresponding position. And if I just quickly take the sphere and hide it, we'll see that the sun, that's where the moon is. The sun's down here. Remember, I've flipped the camera, so it is correct in that I've turned it over as much as possible because it has lined up with where that is. So that was my idea. Now to test it on first of all a HDRI generated from the sky. To mean that I don't have to keep turning the shadow casting off, what I can do is modify the material of this so it doesn't cast shadows, and then I can just use the HDRI settings. So image based lighting, I'll use render in scene even though it won't give us a panoramic projection. Use sky like so. Turn the quality down to 16. I'm going to need high specular output. We are seeing something just here then. Yeah, we're getting something on the inside. That might be enough. Let's give that a quick render. If they're still a bit faint, we can boost that by applying to light source and then increasing the intensity of that, so that acts as a multiplier. So we can see now these specular highlights are where roughly where the light sources are being generated in our HDRI. So let's give them a quick count up. So this being a big blob, is probably multiple light sources. So if there's 24, we can see these look like individual ones. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 5 light sources in there. If the HDRI is rotated, it's resampled, so that they will shift in their distribution. You see a shift in the pattern. Let's rotate it a bit more significantly and see if we see the pattern changing much. It is changing a bit, not a great deal. Another thing we could do is increase the quality setting. So if we take it up to 32, I don't know how many light sources that should generate, but we should see more. You'll notice on the previews here we're only using the lowest quality in the preview settings, and it's the same for the one in the light lab. So as this goes up in quality, that's the default setting, I'll give it a bit of a jump, we should see that they've got a bit faint, but we're getting a very large cluster where the sun is in the sky. So I'll just boost the intensity there to multiply up the output. So you can see now there's a dark patch here. There's quite a few in the sky. They're quite distinctly coloured, and we've got some under the ground. Quite a few under the ground. Now if the ground is an infinite plane and it's blocking off any light arriving from underneath and we're not letting any light through, then if we use sky dome only and use sky, bearing in mind we'll have to reapply this setting because it gets turned off, we should see now that the light sources have been pushed up above the ground. Though it's difficult to count them at this setting, we could do it for the lower setting. So we'll do it again with sky dome only this time, and remember to apply to light source. And what we should find now, okay, right, let's give this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So yes, Horo is right. Clearly more have ended up inside the sun. So even though I've pushed the light sources up that were under the ground, it's actually resulted just in more light sources going into the sun, unless some of these have been doubled up, I don't know. Right, let us try an experiment then with, we'll set the atmosphere as fully white and have a look what a totally evenly distributed sphere looks like. So there we go, a full sphere. I'll apply to light source again, give it some light, and we'll use a higher setting. Let's try 64 and look at the distribution, see how even the distribution is with this. So there's our preview. Okay, so it's a bit of an odd pattern, it's not that regular, but obviously it's got to find some way of breaking the sphere, and there seems to be, you'd think this would result in a dark patch. Let's go higher, let's take it right up. Should manage this, it shouldn't take too long. Yeah, there's a bit of a weird thing going on there, even though we've got perfectly even distribution of light in the HDRI. There is a black hole. I don't know what's causing that. I think it's something that Rashad observed. I'm going to roll this round and see if the hole moves. No, the hole didn't move, which kind of suggests it's a sampling issue in this case. Yeah, because I would have expected that to remain consistently in place. Let's do a sky dome only and see if there's like a half hole appears in that. As you can probably tell, I've not really tested this. Oops, I didn't remember to apply to light source, did I? Just to give it the intensity to give us that. So yes, and a bright spot there. Now I don't know what that's all about, because this really should be a totally even distribution of light sources. Let us try then, before going on too long, let us try one of the synthetic ones that Horo and I have made just here. I'll try this one because it's quite an even lighting. So this is a one that I've created with Horo. So I don't know whether that's going to be enough for us to see at a higher level. Let's try it at 256. Yeah, it definitely looks like there's a hole there, though there's a hole there as well. So I'll just double check by turning it up even more, because this should be a fairly, so you should be almost seeing the pattern of the background, but there's a bit missing, so that's not really right. So I'll have to check with Horo on this. He probably already knows about it and I've forgotten about it, but we'll try this neon wires, and you can see the colour distribution in this quite nicely. We'll go for 256, 128. and apply to light source. Give it a bit of power. See whether that's going to give us a pattern. So you can see that the distribution of this, as the quality goes up, really should be following more closely the pattern of the background, but obviously the light still clumps together in patches. So there you go, a bit of a strange topic for a video. I thought it was potentially interesting to use Bryce to investigate its own functionality. Anyway, the thing is that if you don't have the spherical mapper, then you can still do this experiment. You just lose out a bit of information at the poles. So if I take this out here, take the spherical mapper out, you can still do this test. There's videos on how to make hypertextures, but we'll just lose a bit of information at the pole, so there could be a light source up there that you're not seeing. This is the cylindrical rather than a spherical map that's native to Bryce. Okay then, that's the end of the video. Cheers now.